So scientific notation. What do you know about scientific notation?
Exponent. Isn't it how you write out really long numbers?
Is it how you write out really long numbers? It is.
Long numbers into exponent.
Okay, so it's a way to shorthand long numbers. And in the world of science and people that do number of things, we write, things are written in scientific notation. In fact, your calculators will, for the most part, convert it to scientific notation if the numbers get too big on you. So scientific notation is just using what we already know about place value. So place value goes ones, tens, hundreds, keep going.
Thousands, 10,000s, 100,000s.
Okay. Keeps going on, right? So in scientific notation, the ones place is 10 to the 0 power. The tens place is 10 to the first. The hundreds is 10 squared. 10 cubed makes thousands.
Tens place is the 1.
Yeah. 10 to the fourth is 10,000s. 10 to the fifth is 100,000s. I'll set these off with commas so you can see it. 10 to the sixth is millions. 10 millions, it just follows a pattern. 100 millions. Billions. 100 billions. Or 10 billions, I mean, and then 100 billions. Because we can keep on going. We can get into trillions, and you see the pattern. It go on forever, really big numbers. So I didn't bother to write down everything. This is all in your book on page 182. So if you write down page 182 as your reference point, that'll be most helpful to you. It's all on page 182. You don't have to write it all down. I couldn't even write it straight, apparently. All right. So on average, so we're going to take a number, we're going to put it in scientific notation. On average, the Earth is 93 million miles away from the sun. On average, that's how far the Earth is away from the sun. Let's put that number in scientific notation. So there's a little trick to doing that. You're going to take the numbers that are not 0, which is 93. You're going to put a decimal between the two numbers. And then you're going to write times 10. And you're going to put the correct power, the correct exponent on top.
Oh, geez.
All right. It's the 7th power because we already said that was in the 10 millions place. Now, another way to do that, if you don't have that chart handy, is count how many decimal places it is from here to the end. It's 1, 2, 3, 4, 5, 6, 7. That's how you know. You don't have to memorize the chart to do that. You just count your decimal places. And then you're done. If I said, write 1.5 times 10 to the 8th in standard form, which is write it down as what number this is, I would write 15 and then put, how many zeros would I have to put?
6, 7.
I have to put 7 because I have to move my decimal once to get it behind the 5, and then add 7 zeros to finish it off. That's 150 million. Knowing those place values is helpful. All right. Is that easy or hard? All right. Someone can tell me the answer. You don't have to come up here, but what is this in scientific notation?
3.65 times 10 to the 5. Fifth power.
To the what?
Fifth power.
Is she correct?
Yeah.
Yes. Now, how did she know to put the decimal after the 3 and not after the 6 or the 5? Besides the fact that she just knew it.
You always put it after the first number?
It's always after the first number that's not 0. Okay. The reason why I say that is when we do really small numbers, it's always after the first number that's not 0. Okay. Now, we're not doing really small numbers today, but we will be. So always after the first number that's not 0.
Brainstorm mouse.
25 billion. Start it out for me, please. 2.5 times 10, that's obvious. To the what?
And to the
10.
yeah.
To the 10. Oh snap. Oh snap. Let's go a different way. 3.617 times 10 to the 13th power.
Woo!
Let's make that a number in standard form. How many zeros do I have to put in this puppy?
I'm thinking just.
So we're gonna write 3617.
No, you have to put a little.
10 zeros? Let's see. 1, 2, 3, 4, 5, 6,
I know.
7,
Zeros.
8, 9, 10. Let's check.
I know how to say it.
Dang it!
Can you say
Right.
it?
Yes. It's 36 trillion 170 billion. Yeah.
Yeah. Correct. Correct. Good.
Yeah.
All right. All good?
Yeah.
We're all clear.
All clear?
Enjoy your ride on the course.
That's interesting.
I do.